what are we going to do today? Basically, what we have here, as usual, more coroutines. Coroutines are nice, are very useful, so we have to learn them, how to use them properly. Today, we are going to learn how about the context of the coroutine and how we can switch or change the context while running our coroutines. And last but not least, we are going to learn how to control or cancel our coroutines. So let me share my screen. Here we are. So I share with you the document for today's lesson. You have it in the chat as well as in Slack. We are going to read it a little bit, just as you know, I like to keep a little bit of theory at the beginning of each lesson. So let's go for it. As I said, last week, we learned about scopes, about coroutine builders, how to use launch, how to use run blocking, what are the suspend functions, and how to use async with await. Today, we are going to focus our lesson in about talking about context, how we can change the context, and canceling or controlling the coroutines. As usual, I gave here some links. I think it was this one. Yeah. This link, especially in to the Kotlin manual, will take you directly to the coroutine context and dispatches that we are going to be going through it during today's lesson. So let's go with the theory. We said that we are going to talk about context. Yes, we are going to talk about context, and here you have like a small definition. Basically, what is a context in a coroutine? Well, basically, we always have to execute our coroutines in some kind of context. Okay. Right now, the exercises that we were doing last week, when we were running our coroutines, we didn't specify any context, and we were saying that it was the context was inherited from the coroutine builder, the default context or default scope. The main elements that create a context are two. The first one is the job that we also learned last week. What is it? It's the models, a cancelable workflow with multiple states and a life cycle that culminates in its completion. Last week, I shared an image about the life cycle of a coroutine or of a job. I also shared it this week here, just to remember everything. So when we have a job, it goes through different states, from new to active. From active, it can go to cancel, from cancel to canceled. From active can also go to completing. Completing, it can fail, or we can cancel it. It will go again to canceling and finally to cancel, or it will just finish and complete without problems. So this is one element of the context. Another element is the dispatcher. Dispatcher is defines what thread or pool of threads our coroutine will use to execute the code. As I say here, the dispatcher determines what thread or threads the corresponding coroutine uses for its execution. With the dispatcher, we can confine a coroutine execution to a specific thread. We will see the different threads in 1 second. We can also dispatch it to a thread of pool, or just let it like run and confine without any kind of restrictions or nothing. What kind of dispatchers can we use to change the context in our coroutines? Well, we have here, I specified 4, okay? I didn't specify one more that we can use. It's like creating a new thread because I think it was too much. So basically we have 4. We have the default dispatcher that it will run your coroutine in a different thread if possible. It is by default backed by a shared pool of threads on the Java virtual machine. And it's usually used when we want to run some long-running operations or CPU-consuming operations in the CPU. Okay. Then we have the dispatcher's main. that this dispatcher is platform specific, and it usually runs our coroutine in the main thread, if exists. That means runs in the UI thread, but is not blocking, non-blocking. We will see later what are the requirements to use this thread when we are running our code in Android and Java or in any other platform. Another dispatcher that we have is the IO, or the input-output dispatcher. We will use this dispatcher when we are going to execute or to run some kind of code related to network or disk operations. Okay, this as it is said here, it is designed for offloading, blocking input-output tasks to a shared pool of threads. And finally, we have the unconfined dispatcher. This one always uses the first available thread. It's the most performant dispatcher, and it runs without any kind of restriction. So this is everything that we're going to see about the dispatchers. Now, how can we change the context of our coroutine to one of these dispatchers that we just saw? Well, basically, we have different ways of changing the context. Two of them, we already used them last week. That is launch and async. Okay, here I'm making a difference between these two. We will see why. The third option is the function with context. With context, it is used to get a result from another thread, doesn't block the thread where it is called, and this is important, runs in sequence. And another thing that I missed here is that with context is a suspend function. That means that the thread will be suspended at that point until the coroutine finishes, and then it will continue with the execution of the rest of the code. Then we have launch and async, but when we are not expecting any result. Used when we don't need any result, doesn't block the thread where it is called, runs in parallel, big difference with context, that runs in sequence. So here, when we are launching the coroutine, it won't stop at that point, it will continue with the rest of our program. And then one difference is that launch rethrows exceptions in case there's some, while async holds the exception until we know await to wait for the result. So async will keep the exception until we call this, while launch will just throw it as soon as they are showing up. And then finally, we have async, but when we are expecting for the result, when we need to wait the result and can run in parallel for efficiency. This is important. It blocks the thread where it is called because it has to wait for the await to finish, and runs in parallel as well as these guys. So we have three options. With context, to run in sequence, when we want the result from another thread, doesn't block. Launch async when we are not expecting for the result, runs in parallel, doesn't block the thread. And finally, async when we are waiting for the result, also runs in parallel and blocks the thread where it is called. Okay? Any questions? Anyone? Something that is not clear? Okay, if no one has questions, I will continue. So the next section is about canceling or controlling coroutines. This graphic or this life cycle of the job, I already explained it, so I'm not going into it again. And I'm just going directly into the functions that we can use in the job instance to control the job. The first one is cancel. Cancel, as the name suggests, cancels the job, but it cancels it immediately. It doesn't wait for completion of the cancellation. Okay, so we call cancel and bam, the job is canceled. We don't want to know anything else about it. Then the other function that we have is join. When we call join from a coroutine context in a job, it means that we want to wait for that coroutine that we call to complete. And then at that point, it will continue the execution. We can combine cancel and join together to cancel the job. And once the job finishes canceling, then we will continue with the execution. Whereas cancel, as I mentioned before, we cancel the job and we continue. We don't care about the status. Another useful function that we have is cancel and join. Guess what? It's the same as if we run cancel and then sequentially we run join. That's the same. Cancels the job and suspends the invoking coroutine until the cancel job is complete. And finally, we have two more useful functions that we can use to control our coroutines. One is with timeout. That is helpful to use when a job might be taking too long to complete. For example, we are doing a network call that it can take a very long time, but we want to limit it to 5 seconds. So if it takes more than 5 seconds, this timeout, the timeout will be reached, and it will cancel automatically the coroutine or this call to the network. Something very important, and is the main difference with the next one, is that this function runs a suspending block of code inside a coroutine and throws a timeout cancellation exception if the timeout is exceeded. Okay, when we are exceeding the timeout, this exception is thrown. We can, of course, we can handle the exception, but here it is. And last but not least, we have this function with timeout or null. Guess what? It does the same as the previous one, but instead of throwing the exception, it returns null in case the timeout was reached. Okay, so we have 5 functions. Could be 4, because these two, as I said, can be turned into this one to cancel and join. And that's it. Any questions about controlling the coroutines? Nothing? Okay, so let's go directly to the tasks. As usual, let's open our friend, IntelliJ. Let's create a new project. Let's choose, as usual, Gradle, and inside of the Gradle thingy, Kotlin JVM. We click next. We give it a name, lesson 7, for example. Let's finish. I'm going fast because we should be already masters on creating projects here. Next thing we have to do, as same as last week, we copy this line and we add it to our build Gradle file inside of the dependencies. Once we have it, we click on the elephant icon. Here, in my case, I don't know in your case where it will be. Okay, I can hide this step. Next step, as usual, let's create our main file with this code that we are just going to copy paste. Here, new Kotlin file, main. Please let me know when you are all here. Just give me a yes on the participants list or whatever. Okay, we have 4 yes, 5. Let's continue. And we have something in the chat. Okay. So let's follow the tasks. We have this. Let's run it and see that it works. I don't know if I'm running. Okay. Now, yes. Okay, so we have the run block in block, 2 variables being defined here that we are going to change them to bars. We have one print line showing that we are starting in the thread main. Then we are printing the results. That is just a concatenation of the 2 variables, results, result 1, result 2, and we are ending in thread, the same thread. So next task, suspend functions. Let's create 2 suspend functions, function 1 and function 2. Function 1 has a delay of 1 second, and function 2 has a delay of 100 milliseconds. Each function prints and returns the string function 1, function 2. So here, for example, suspend function 1, I said that returns a string. Okay. Function 1 has a delay of 1000. Its function prints and returns the string function 1, function 2. Okay. So we can do, for example, result function 1, print ln result, and it will return the result. We have function 1, we copy, we paste, change the name, and change a couple of things like this. Is everyone here? Okay, perfect. Okay, so let's continue with the next task. Let's start playing with the context. For example, before starting with this function, last week we learned that in order to execute this or to launch these coroutines, we would do something like, for example, launch function 1 and the same way function 2. If we run this code, we see we are starting in thread main. We are printing the results. Why? As we explained before, launch is not suspending the function. It's not a suspending function. That's why it continues with execution. The next thing that we see is the result, ending, and then function 2 and function 1. Here, it's okay. The order is correct because function 1 it takes longer. It has a longer delay than function 2. So until here, everything is correct. Now, the main thing. Let's go with the context. In the main function, run the previous functions in the dispatcher's IO context. So the only thing that we have to do is, instead of launch, we call with context. And you see that with context expects the context here between the brackets or the parentheses. So the only thing we have to do is dispatchers.io. And the same we do with function 2. one thing that I mentioned here on the beginning is that we are using with context when we want to get the result from another thread. So we want the result from this function 1 and function 2. What do we do? Well, we can basically assign it. Result 1 equals this. Result 2 equals this. Let's run it. Well, here we are. As we can see, we are starting again in the thread main. We can do one more thing to see how it's switching the context. Here we are returning function 1 and function 2. We can add thread current thread.name as we are using here in this line, just to see which thread it is running on. So we are doing like this in both, and I'm running again. So as you can see, we are starting in thread main. We are switching the context. Function 1 and function 2 are being executed in this thread, in default dispatcher worker 1. And finally, we see the results, function 1, function 2, whatever we specified, and the thread finishes. So everything is sequential. We are switching the context. We are executing our coroutines in a different thread. And we have everything quite nice. What's the problem here? Well, as you can see, function 1, it finishes sooner than function 2. But function 1 takes longer. Why this is happening? Again, with context, runs everything sequentially. So we're calling with context. This function is executed. Once it finishes, then it continues to the next line. That's why we have this incorrect order. Is it okay? Understandable? Any issues? Questions? Perfect. You see that this is a very simple example just to show how with context is working. Now, the next one is let's play with launch. Let's replace the previous with context with launch. The only thing we have to do is change with context with launch. So I'm doing like this, I'm doing launch. When you replace it, you see that it is complaining. And why it is complaining? Well, we saw it also last week that launch returns an instance of the job, while here we are expecting string. So how can we get the result of the function to be used in the following line or whatever? Well, we can do like this. Cut this part and put it inside of the coroutine, and we are done. No more complaints. Let's run it. You see what happened here. We're starting on the main thread. Launch is not a suspend function. That means that it's not going to stop here until the coroutine finishes. It will continue with the execution. So it's printing next the results with result 1 and result 2. So this variable was not modified. Then prints the last message. And finally, we have the results from the functions. Here we see that function 2 finished earlier, finished sooner, so as we are expecting. And it was running in this in another thread, not in the main thread. And then we have the results from function 1. Correct order, the only thing is that we are not waiting for the results when we are calling launch. Very easy, right? Does anyone have any problem? Okay. Let's continue playing. So we have launch with only one task. Let's do the same with async. Replace the previous launch with async. Easy peasy. We go to launch with this, replace it with async. And here, what we can do is to get the result, we need to call await on the jobs. So we'll have to get rid of these two variables at the beginning. We don't need them. And here, okay, we need them here. Result one. We do it like this. And let's put it also here. Two. And as we learned last week, to get the results from calling async, we have to call here await and await. If we run this code, here we have it. So as usual, we are starting on the thread main, on the main thread. Then the coroutine that we launched or that we called with async function 2 finished sooner than function 1 as expected. Everything sequentially. Now we have the results in the correct, in a correct order. That means these two coroutines were launched, were executed, and here we were waiting for both results. Once we got both results, the execution of our app continued. That's why we could see the results after the printing from the functions. And finally, ending in thread main. So now you have seen the difference when we are calling with context, launch, and async with the same suspend functions, how they are behaving, what's their behavior, how they react, how you can get the values from the functions. You see it. Everyone managed to run this code or to make it work? Perfect. I see a lot of greens, so that's a good thing. Okay, let's continue with the next. This one. Finally, we are going to play with the coroutine jobs. Okay, so we described like five functions, if I'm not mistaken. Yeah, cancel, join, cancel and join, with timeout, and then with timeout or null. Let's start with cancel and join. If you want to keep this code, you can just comment it out. For example, this two and this, and let's start somewhere here. We are not going to make use of these two suspend functions, so we can also comment them. And yeah, we can have it like this, okay? Something clean that we can start with, and you can keep your old code. So what are the tasks in these functions while playing with coroutines? Well, the main thing, let's launch a new job. The context here doesn't matter, okay? What we want to do is just control our coroutines to see how we can cancel, how we can do some things with them. Launch a new job, which repeats 300 times. Maybe I added too many times. I don't know if 300 or 200, whatever, we'll see. Then it prints the job is waiting and has a delay of 50 milliseconds. Let's start with this one. Launch a new job. How we are launching a new job? Well, the name says it all. Launch. We are not specifying the context because as I said, we don't care at this point. Which repeats 300 times and print job is waiting. Repeats 300 times. Let's use the nice things of Kotlin. Instead of using a for loop or whatever, we can use repeat, specifying how many times it's going to repeat. And that's it. If you want to know what's inside of repeat, just hold the command key on Mac or Alt on Windows and click on it. And you can see that it's a for loop from 0 until X times, whatever. It's exactly the same, but in a more nice way. Here we need to print the job is waiting. So print ln job is waiting, and it has a delay. Is this? And it has a delay of 50 milliseconds, if I'm not mistaken. Yes. Okay. Let's run it. Job is waiting, job is waiting, job is waiting. 300 times it will print. How do we know how many times it's doing it? Well, as you can see here in the same line of repeat, we have this parameter here that we can rename. For example, iteration, we can do it like this. And here we do like iteration. Okay, we are using this value that the repeat is giving us in the action int units. Okay, it's not showing here. But we can use it just to know in which iteration we are. As you see now, it's a little bit nicer. We see that it's taking quite a long time. I don't know how long, but at least 10, 15 seconds. It does the 300 iterations and finishes. Good. We have what we wanted. Now, the next task. Let's cancel the job after 2 seconds. It's taking too long. We don't want to wait too long. What can we do? As I said before, and last week, launch is returning an instance of this job. So let's get the job like this. Now we have a reference to the job that we are launching. We can do something with it. Job cancel. But we have to wait 2 seconds. So let's cancel after 2 seconds. Let's run it. 2 seconds, 36 iterations, and our coroutine finished. Here is what I said at the beginning of the lesson. Cancels automatically the coroutine without waiting for the completion of the canceling. Okay, what if we want to cancel but also like set some variables or just liberate some memory or whatever? What can we do? For that, we have job.join. As I said, it will wait for the completion of the coroutine to continue with the execution of the code. So we're canceling, we are doing something to cancel the coroutine, we are waiting for it, and then it will continue everything. If we run it this way, we won't see any difference. So to make it a little bit more visible, we can do like this. We can surround or wrap our code inside of the coroutine in a finally structure. And here we can print finishing job. Okay, I'm going to run it again without the job join, and you will see. You see what happened here. Our job was here, 37 iterations, it was canceled. It was canceled and immediately it was printed this message because we didn't wait for the job to completely finish, even the cancellation. And at the end, we got the finishing job. If we add join and we run it again, once we go to the 36, 37 iterations, doesn't matter, we are waiting for the job to finish completely. Even if it was canceled, we want to make sure that it was finished. And then we print the last message in our code. As we said before, we have one function that is cancel and join. That is doing exactly the same as these two functions, but combined in one. We run it, and you see the same output. Job finishes on iteration 36. It shows this message, and then it continues with the rest of the code. Is it clear? Does anyone has any question, any problem? Is it working for you? Okay, perfect. And let's go with the last part of this lesson, which is let's use with timeout and with timeout or null. Easy peasy. Let's replace the previous launch with timeout and set the timeout to 2 seconds. So we don't need to keep the reference of to the job anymore. So we can remove these guys. And instead of launch, we are going to write with timeout. And as you can see, with timeout expects a parameter, the timeout amount. And we said that it's going to be 2 milliseconds, 2 seconds, 2000 milliseconds. Okay, let's run it. After 2 seconds and on iteration 36, we are having the same thing. The job is finishing and we got the exception. So it's a timeout. What happens if, for example, the code that we have here finishes earlier than the timeout? For example, let's add 10 iterations. Nothing happens. We don't get an exception. The job finishes as we are expecting. But if there's a delay, for example, in a network call or whatever, and it's taking like 3,000 or 300 iterations, we got our exception. And the last one that we are going to, the last function that we are going to use is instead of with timeout, we are going to use with timeout or null. With timeout or null. Here we go. We can run it. The timeout was reached. We see nothing happened here, but the thing is that we can control what happened. For example, we can assign this to a variable, job. Yes. And then check, for example, if job is null, we are going to print it's null. And if not, we can print just to make sure it's not null. Let's run it. Here we are, iteration 36. The timeout reached the value, finished or canceled the coroutine. We check that is null, and we are ending in the main thread. Again, let's reduce the number of iterations to 10 and run it. We finish the job. It's not null. That means that the timeout wasn't reached, and we are finishing our code. So what do you guys think? Was it clear? Do you have any questions? Any problems? If there are no questions or problems, okay, I see something in the chat. Everything is clear. Okay. Perfect. So if there are no questions and everything is clear, so that was my presentation for today. I hope you liked it. And let's go for next week, another one about coroutines.
Thank you very much, Juanvi. Great presentation. And thank you everyone who joined today, and see you next week.